Find the volume of the treehouse. Okay, so if you look at the treehouse, you see that it has a top part, the roof section, and then it has the bottom section. And we can identify those two shapes. The top section is a triangular prism. And we know the formula for a prism is volume equals area of the base times the height. And since we have two different shapes in this treehouse, we have a triangular prism and we have a rectangular prism, we're going to have to find the volume for both shapes separately. So go ahead and draw your T-chart. And this is going to be the formula for the triangular prism. And this will be the formula for the rectangular prism. And the formula for the rectangular prism is real easy. It's just length times width times height. But let's follow the steps. The first step is we need to identify the base. We want to draw the shape of the base underneath the V. So the shape of the base is a rectangle. And we know that the formula for area of a rectangle is just length times width. So instead of using capital B, I'm replacing capital B with the area formula for a rectangle. And then don't forget to multiply that by the height. So let's take a look at just the rectangular prism measurements. We have 4 feet, 6 feet, and 6 feet. So in any order, let's plug those measurements into the formula. Plug and chug. So 4 times 6 times 6. 4 times 6 is 24. 24 times 6, let's see what that equals. 24 times 6 equals 144. So don't forget to write your unit of measurement cubed. Separately, we need to find the volume of the top section of the treehouse, which is the triangular prism. So let's identify the base. Recall that the base of a triangular prism is a triangle. So underneath the V, I'm going to draw a triangle representing the shape of the base. Now underneath the capital B, I need to insert the formula for area of a triangle, which is base, lowercase b this time, times h divided by 2 times the height of the triangular prism. A couple of things here. Notice we have two h's. We have the height of the triangle, which is 2 feet. So the height of the base is 2 feet. The height of the entire prism is 6 feet. Well, how do I know that? Well, the height of a prism always connects the two bases. The height of the prism always connects the two bases. So even though you can't see another triangle on this side of the treehouse, it's there. So this edge here connects the two bases, therefore it's the height. So let's plug in our measurements into our volume formula. The base of the triangle is 4 feet, right here. This is 4 feet. That's the base of the triangle. The height of the triangle is 2 feet. Don't forget to divide that by 2. Times the height of the prism. Again, the height of the prism connects the two bases, so that's going to be 6 feet. So 4 times 2, we always work the numerator first. 4 times 2 is 8. 8 divided by 2 is 4. 4 times 6 is 24. And do not forget your unit of measurement, 24 feet cubed. Volume is always cubed because it represents a three-dimensional measurement. So now we're not done yet because we need the entire volume of the treehouse. So we take the 144 cubic feet plus the 24 cubic feet of the top of the treehouse to get the entire volume of 168 cubic feet, or 168 feet cubed. Okay, next question. A square pyramid is constructed from the cardboard model shown below. What is the lateral area of the pyramid? Well, let's define lateral. The difference between lateral area versus total surface area is the lateral area does not include the bases, so no base. The total surface area is the lateral surface area plus the area of the base. Well, let's take a look at this net. This net represents a pyramid. It tells you that in the problem. It's a square pyramid. The base of the pyramid is this square. It's a 6 by 6 square. So we are not going to include the area of the base when we find the lateral area. So what we need to do is we need to find the area of this triangle. And we know the formula for area of a triangle is base times height divided by 2. So let's find the measurement of the base. Well, we know the base and the height are always the lines that are perpendicular. What does perpendicular mean? Well, perpendicular is when the base and the height meet, it creates a 90-degree angle, just like you see here. So the base of this triangle is 6, the height of the triangle is 9, and we're going to divide all that by 2. So 9 times 6 is 54, divided by 2 gives us 27, and area is always represented with the unit squared, in this case inches. Well, we're not done yet, because notice we have to find the area of, let's see, 4 triangles. So I'm going to take this area measurement of one triangle and multiply it by 4, and I get 108 inches squared. So the lateral area is 108 inches squared. And just keep in mind, the lateral surface area does not include the bases, or in this case the base, because the pyramid only has one base. The total surface area does include the base with the lateral surface area. An ice cream scoop has the shape of a hemisphere, or half of a sphere, with a radius of 3 centimeters, as shown below. What is the approximate volume of the ice cream scoop? Well, we're going to use the formula for volume of a sphere, what you see here, 4/3 times pi times radius cubed. And let's just plug in our single measurement that we need to find, which is r, radius. So I'm going to rewrite this formula. 4 times, I'm going to round pi to 3. 4 times 3 times the radius cubed, and then I'm going to divide all that by 3. So notice the original formula is a little more confusing than the way that I rewrote the formula. What I like to do is I like to multiply 4 times pi times radius cubed first, and then divide all that by 3 to get our final answer. Now PEMDAS, of course, says to work the exponent first. So let's look at 3 cubed. 3 cubed is the same thing as 3 times 3 times 3, which equals 27. So 3 cubed equals 27. 4 times 3 is 12. So we're going to multiply 12 times 27. to get 324. So now we have 324 divided by 3. And I can look at that. 3 goes into 3 one time, 3 goes into 24 8 times, so that equals 18. Let's see, 18 centimeters cubed. Excuse me, that would be 180 centimeters cubed. Excuse me, 324 divided by 3 is 108 centimeters cubed. Now this is the volume measurement for the entire sphere, but we don't have an entire sphere. We have a hemisphere. We have half of a sphere. So we need to take our measurement and divide it by 2 to represent the hemisphere, the half of a sphere. And I know 108 divided by 2 is 54. And notice that in the answer, we don't have any answer that's exactly 54. But key in on the word approximate. Approximate the volume. So we want to find the answer that's closest to 54, and that would be answer choice J. Okay, next problem. A spherical exercise ball has a diameter of 2 feet, as shown below. What is the closest to the volume of the ball? So first step is to write the formula as you see it on your math chart. 4/3 times pi times radius cubed. Well, we need to find the radius, and some students make the mistake and they mistakenly put the diameter in for the radius. Well, we know that the radius is going to be half the diameter. The diameter in this example is 2 feet, so the radius has to be 1 feet. So we're going to use 4 times 3, we're rounding pi, times radius cubed, so 1 cubed is just going to be 1, and then divide all that by 3. So we have 4 times 3 is 12, again 1 cubed is 1, so we have 12 divided by 3, which equals 4. Don't forget the units, cubed. 4 feet cubed, so answer choice B. Next problem. A cylindrical manicotti pasta shell has a radius of 1 inch and length of 6 inches, as shown below. What is the approximate lateral area of the shell? So first, let's look at the answer choices. They're spread out pretty far apart, so it's safe to round pi to 3. So let's rewrite this formula and plug and chug. 2 times 3 times my radius times my height. 2 times 3 is 6, times 1 is 6, times 6 is 36. So our answer should be 36 inches squared. Again, area always has units squared, volume has units cubed. Because we rounded pi down from 3.14 to 3, our answer is going to be a little smaller than the answer given to us, so the correct answer is going to be C. Next question. Yadira made a wooden cone with a radius of 1.9 inches and a height of 15 inches. Which of the following is the best estimate of the volume of the cone? So first thing is, let's write down the formula for volume of a cone. Volume equals 1/3 capital B times H. We're going to draw our T-chart every time we're solving volume, and we're going to draw a picture of our base. A cone has a base of a circle. So now let's rewrite the formula. 1/3. Now, instead of using capital B, we're going to replace that with the formula for area of a circle, which is pi times r squared, and then bring down the h into the formula. Okay? So capital B in the volume formula always stands for area of the base. We identified the base as a circle. We substituted the formula for area of a circle into the formula. Now, let's look at our answer choices. They're pretty spread apart, so we can probably get by with using 3 for pi. So we have 3 times the radius, 1.9 inches squared, times the height is 15. So let's calculate 1.9 squared. PEMDAS says work the exponent first. So 1.9 times 1.9 is, move your decimal 2 places, so it's 3.61. So now we have 3 times 3.61 times 15. So now let's multiply 3.61 times 3. Move your decimal, we get 10.83, and then don't forget to multiply that by 15. So we get, let's see, move your decimal 2 places. So we get 162.45. Because we rounded pi, the closest answer to our answer is 180 inches cubed. Now, I recommend that you use a calculator, and instead of using 3 for pi, okay, we're not done yet. You know what I forgot to do? We have to divide, we have to take 1/3 of that. So we need to divide that by 3. So we take 162.45, divide that by 3. Let's see, so we get 54.15. So the closest answer to 54.15 inches cubed would be answer choice A. Correct answer is answer choice A. Now, common mistake, let's reflect on this. The common mistake that I see when you're solving for volume of a cone is you do what I almost did. You forget to, after multiplying the area of the base times the height, you forget to divide that number by 3. Okay, so be sure to do that.